In this demo, we are going to work through a mean CVaR portfolio selection problem. This was also shown to you during the Certified Portfolio Management program at Columbia. What we're going to do is work off of the Black-Litterman model that was part of the other demo, the Black-Litterman demo. We're going to start with the market portfolio and then try to modify this market portfolio and to see how what happens when you use a mean CVaR characterization as opposed to a mean variance characterization. What you don't see very clearly down here is the market portfolio getting from the Black-Litterman model. So I'm going to copy this and paste it here. And if you see on this plot over here, you're seeing that the market portfolio and the mean variance portfolio is exactly the same. Now what I'm going to do is copy this return value and paste it here just as a value. So I've got 1.42%. I'm putting a margin constraint of 0.5. Margin basically means how much negative positions you're holding. The market portfolio doesn't hold anything negative, so it's got 0. Now what I want to do is restrict this to, let's say, 0 again still. So I'm putting the bound of 0. And now I know that the market portfolio is the mean variance optimal portfolio. Instead of doing mean variance, now I'm going to mean CVaR. Now mean CVaR, in order to run this optimization problem, I need to get scenarios. So what I've done here is looking at the mean vector and the covariance matrix coming from the Black-Litterman model. I have generated 50 scenarios. In general, you're going to need a lot more scenarios than 50 scenarios to figure out what the mean CVaR portfolio problem is going to be. This is for illustration purposes so that it works in Solver and I'll be able to create an output. So I'm going to go to Solver and it sets up the constraints. It's trying to change the CVaR value by changing various components. All the portfolios have to be added up to 1 and so on. If I solve this, it finds a new portfolio. And now if you compare to what happens to the mean CVaR with respect to the market portfolio, it's exposing a lot more on US bonds. It doesn't add up to 1 again. Remember, there is a risk-free asset that I could take. So it's putting 77% in US bonds and like 6% in US large cap value, 4% in US small cap, 3% in small cap, US small cap value, almost nothing in emerging markets or international bonds. What it's trying to do is be very sensitive to tail behavior. It expects the same expected return, but now since it's very sensitive to the tail behavior, it's going to try to put as little position as possible in situations where there's likelihood of tail behavior, which might be in the international bonds and in the emerging market and international developed equity. So it doesn't expose itself at all to there. This gives you the positive side, what's happening to the mean CVaR. It's very sensitive to tail behavior and it's taking action because of that. The bad part is it tends to give you portfolios that are not as diversified because the number of samples that we have taken are small. Another thing is that because of the number of samples are small and we are using these samples to actually construct the portfolio, we have to be worried about whether the conditional value at risk that we are going to get out of sample is going to be close to the conditional value at risk that we got in sample. Within sample, we got a conditional value at risk of 0.1027 or 10.27%, and we got a return of 1.42%. But out of sample, we get a return of only 8.25%. We get a CVaR of 12%. The return drops and the CVaR goes up. This is a classic problem of having very few scenarios. That said, it's a very flexible model that's able to take scenarios of any kind and construct for you portfolios that are able to give you a flavor of behavior where it protects against tail behavior. So that's pretty much it for this particular module. We will discuss more in the next year when we see you again. Thank you. Bye-bye.